Hey there, my name is Hydrogen Heather and I would like to welcome you to today's experiment of the day. And let me just tell you, this is hands down my favorite experiment of all time. I've done this in the classroom for the last 20 years, personally in front of more than 100,000 students, and it remains my favorite. And I think the reason is, it's so simple, you can literally do it right at the dinner table, and we as a family have done it several times, so let's dive right in. So I'm gonna start with a question. Do you remember or have you ever played a game called Octopus Tag? It's one of the most hilarious forms of tag you'll ever see, and let me just ask, have any of you played Octopus Tag? Okay, maybe not, so this is something you've got to do with your friends. Here's how it goes. The person who is it starts to chase all of the other children around, and they've got to have some kind of a boundaries, so maybe this room. When the child comes across the first other person that they can catch up to, they don't tag, but they grab hands. And then these two together are the octopus, and they run around and grab the next person's hand. And what naturally happens, which is so hilarious, is that as the game progresses, you've got these children linked arms or holding hands flying all around. The person on the end of the line gets swung around, the hands get let go of, the hands come back together, and it's just this funny, hilarious mess. Today's experiment is a little bit like that. I call it the milk explosion, and all you're going to need are some small bowls to hold the milk. You're going to need all 4 colors of food coloring from your pantry. You're going to need 1 toothpick per child, the soap right from the side of your kitchen sink, and then some milk. So the first thing is, I'm going to pour maybe about 1 inch or 2 of milk. There's no exact measurement, and as you can see, I've got my 3-year-old right next to me. And this is kind of good because you can do this from age 2 all the way up. Yep, we're gonna leave that there. And you see what 3-year-olds want to do. This is appropriate all the way up through middle school. And the biggest problem that you'll have is when you're working with little ones, or even if you're working with older ones, is everybody wants to grab and move the bowl. So direction number 1 in this experiment is, do not touch the bowl. I'm gonna put our bowl right here, and then I'm not gonna touch it again. I'm gonna put your bowl right here. Do not touch the bowl, no touch, okay? So what we're gonna do is we're gonna take our first color from the food coloring. It doesn't matter which one that you go first, that you choose first. And we are going to put a total of about maybe 4 or 5 drops. So I'm gonna do 2, and then you may do 2. Okay, and then I'm gonna hand it over to you, and Nevaeh, you put your 2 in, and then help Daniel put his 2 in. Now, what you'll find with little ones is that they wanna squeeze very hard. And that's okay. So we got a couple of extra drops there, and that's no big deal. And if it gets on our hands, we just wash when we're done. So now we're gonna move to the second color, and this time I'll let the 2 of you go first. So now we have about 4 or 5 drops of red. And we're gonna get about 4 or 5 drops of green. Good job, you 2. So I'm gonna do 2 drops, you do 2 drops. And I want the 2 of you to start on blue.
Ready?
All right, very nice work. And remember, don't touch the bowl. So do you notice how my 3-year-old Daniel here, every time he leans over, it's a likelihood that he's gonna lean his arms on the bowl, which is why when I do it with little ones, just constant, gentle reminders, don't touch the bowl. We're gonna hold the food coloring over the bowl. And then you'll even find that with middle schoolers too. As they lean over, they wanna lean against the bowl. But the reason we're so strong on that is that we do not want the milk to move. We do not want the milk to move. Okay, so we're finishing up with yellow, and then I'm gonna pass it over to Nevaeh and Daniel. Okay, now I'm going to ask the 3 of you a question. Do you notice that that food coloring is staying right where you put it?
Yeah.
Okay, there's a reason for that. And I don't know if you can get the camera angle in or not, but what we're seeing, what you'll see is that food coloring stays put. So there is a reason for that. And I want you to take your hands and I want you to do this. All right, food coloring is made mostly of water, and water molecules have a very interesting and strong property. water molecules love to hold hands with each other, and they hold hands tight. And the word for that is cohesion. Say that word with me. Cohesion. All right, so everyone show me cohesion. Now show me non-cohesion. Now show me cohesion. All right, you've got it. It's the water molecules holding hands. And the reason that the food coloring is staying in place is because since nothing is disturbing it, all of those water molecules making up the food coloring are just patiently sitting in place holding their hands. But now we're going to introduce a little bit of a chemical change here. I'm going to put just a little bit of soap at the bottom of these 2 cups, and I'm going to make sure that everyone has a toothpick. And now I want you guys one more time, show me cohesion. All right, show me non-cohesion. All right, good. Now here's what we're going to do. At the very same time, we are all going to pick up, here, I'll put this here so you can reach. We're going to pick up our toothpick out of the soap. So there's a little bit of toothpick a little bit of soap at the end of the toothpick. And all we're going to do is watch. We're going to gently touch the food coloring and take our hand back. Oh my goodness, look at that. Now let's just go ahead and do it one more time. And I'm not sure how much you can see on camera, but I can tell you that we are seeing this vibrant, brilliant, exploding of colors. Okay, oh, I know, I see that, that's the best. Now take your toothpick and put it back in the cup. Now, I want to ask you a question, okay? Show me cohesion one more time. Now, I have not asked these guys this question ahead of time. What do you think that the soap did to that cohesion? That's it. When the soap went in there, all of that cohesion got broken up. Now, here's where the Octopus Tag comes in, okay? Not only is the cohesion being broken up, but if you go onto Google and really read in depth for this experiment, I'm going to keep it simple here. What's going on is that there is also fat in the milk. So when all of the cohesion is broken up by the soap in the water molecules, the fat molecules in the milk and the water molecules in the milk and the food coloring almost have this game of octopus tag going on. So the molecules are grabbing each other and literally dragging each other across the milk, but then as the soap recycles and goes through, bonds are broken, whoa, but then they're re-grabbed and they're dragging each other again. So right now, I can tell you, our bowls look calm. But as more of the soap recycles up, as long as we don't disturb that bowl, the soap is gonna recycle up and that game of cohesion and bonding and octopus tag is going to continue on. And then when you're done, you just rinse the bowl, you're all finished. I hope that you have enjoyed my favorite experiment of all time, the cohesion milk explosion, and we'll see you right back here again tomorrow.